D-Wave. Real-world quantum computers now. D-Wave was founded in 2019. It has more than 200 patents. At the current burn rate, they have enough cash to last 10 years. D-Wave's quantum computers are specialized for a category of problems called optimization problems, tasks that involve finding the best possible solution among many possible configurations. Unlike gate model quantum computers, like those from IBM, IonQ, or Rigetti, D-Wave uses a different approach called quantum annealing. This makes it well suited for certain types of computational challenges. 1. Core strength: combinatorial optimization. D-Wave systems excel when you need to minimize or maximize a complex function with discrete variables, especially when there are many interdependent choices. Common optimization examples: logistics and supply chain vehicle routing, e.g., shortest delivery routes with time windows; scheduling, e.g., factory shifts, aircraft crew rotations, or hospital resources; manufacturing and operations of minimizing waste in cutting or packing problems; optimizing assembly line configurations; energy systems; smart grid load balancing; optimal power flow; portfolio management, asset allocation under risk constraints; hedging, and derivative optimization. These problems can often be formulated as a QUBO, quadratic unconstrained binary optimization. This is D-Wave's native problem format. 2. Other problem domains where it's effective. A. Machine learning and AI. D-Wave systems can be used for feature selection, finding the best subset of features for a model; clustering grouping data points optimally; training Boltzmann machines, a type of probabilistic neural network. While not yet outperforming classical GPUs for large-scale AI, D-Wave provides alternative heuristics that can help escape local minima in training or tuning. B. Drug discovery and materials science. Protein folding and molecular structure optimization. Quantum chemistry approximations. Energy minimization problems. These are often formulated as spin glass or Ising model problems, a natural fit for D-Wave's annealing hardware. C. Cybersecurity and network optimization. Network traffic routing and load balancing. Intrusion detection, optimization of sensor placements and resource allocation, cryptographic key distribution simulations, deconstraint satisfaction and scheduling. Any problem that involves satisfying many competing rules simultaneously, such as workforce scheduling, employees versus shifts versus regulations, air traffic control slotting, production planning. These are classic D-Wave use cases. Companies like Volkswagen, Toyota, Lockheed Martin, and Save-On Foods have published case studies using D-Wave for exactly these kinds of problems. 3. Why it's good at these. D-Wave's quantum annealers explore many configurations of a problem in parallel, using quantum tunneling to escape local minima. This process can yield better optimization outcomes than classical algorithms like simulated annealing or genetic algorithms, particularly for rugged energy landscapes. 4. Where it's not ideal. D-Wave is not a general-purpose quantum computer. It is less effective for Shor's algorithm, factoring large numbers; Grover's search algorithm, quantum simulation of general physical systems; arbitrary quantum logic circuits. Those are areas where gate model quantum computers, IBM, IonQ, Google, etc., are stronger. D-Wave suitability by category. Examples: D-Wave suitability, optimization, routing, scheduling, portfolio selection, 5 stars; machine learning, feature selection, clustering, 3 stars; materials science, molecular/energy minimization, 3 stars; simulation/physics, quantum chemistry, condensed matter, double star, cryptography/factoring, RSA breaking, etc. Real-world D-Wave use cases that show what kinds of problems it's solving today and for whom. These examples come from public D-Wave case studies, academic papers, and partner announcements. 1. Volkswagen. Traffic flow optimization. Goal: reduce congestion and travel time in urban traffic. What they did? Volkswagen used D-Wave's annular to optimize routes for taxis in Beijing during rush hour. The problem? Minimize total travel time across multiple vehicles while avoiding overlap on congested routes. A classic combinatorial optimization challenge. They demonstrated that D-Wave could generate real-time routing recommendations faster than classical heuristics. Result: reduced overall traffic density and travel time in simulated tests, later extended to traffic flow analysis for Lisbon and Barcelona. 2. Airbus. Aircraft scheduling and loading. Goal: optimize how aircraft are loaded, maintained, and routed. What they did? Airbus worked with D-Wave to develop quantum annealing formulations for aircraft loading, determining how to place cargo to balance weight, fuel, and capacity. This problem involves tens of thousands of variables and constraints, which is ideal for D-Wave's QUBO model. Result: demonstrated reductions in load imbalance and improved logistics efficiency in test environments. 3. Lockheed Martin fault detection in spacecraft systems. Goal: diagnose anomalies in complex control systems. What they did? Lockheed partnered with D-Wave to explore model-based reasoning and fault isolation using quantum annealing. The problem was framed as a constraint satisfaction task. Find the most likely fault configuration explaining observed sensor readings. Result: proof of concept success in narrowing down faults faster than traditional Bayesian reasoning models. 4. Save on foods. Grocery supply chain optimization. Goal: improve delivery efficiency across hundreds of stores. What they did? D-Wave helped the Canadian grocery chain model its distribution scheduling problem. Using hybrid quantum classical solvers, they optimized truck routes and delivery times to minimize both fuel costs and spoilage. Result: reported measurable improvements in delivery timing and cost efficiency, as published in D-Wave's 2023 commercial case study. 5. Los Alamos National Laboratory Machine Learning. Goal: improve clustering algorithms for large data sets. What they did? Researchers implemented quantum-assisted clustering on D-Wave to group high-dimensional data. The annealer helped find cluster assignments with lower total error compared to k-means on certain data sets. Result: demonstrated that quantum annealing can enhance unsupervised learning performance for noisy, complex data distributions. 6. Deloitte and D-Wave workforce scheduling. Goal: assign staff to projects under skill, budget, and timing constraints. What they did at Deloitte's Quantum Lab used D-Wave to optimize consultant-to-project assignments in large organizations. This used D-Wave's hybrid solvers to handle real-world constraints that exceed current qubit counts. Result: achieved near-optimal schedules with fewer computation cycles and better resource utilization. 7. Biotech and pharma. Protein folding experimental. Goal: find low-energy conformations of small protein fragments. What they did? Researchers encoded simplified protein folding problems as Ising models on the D-Wave annealer. Although limited by qubit count, the approach successfully identified low-energy configurations faster than classical simulated annealing for small systems. Result: proof of concept for applying annealing to drug discovery optimization. 8. NASA. Mission planning and scheduling. Goal: allocate resources for multi-satellite operations. What they did? NASA Ames used D-Wave to explore resource scheduling for Earth observation satellites. Each satellite's time window, battery state, and data link constraints formed a massive optimization problem. Result: early tests showed feasible solutions with improved computational efficiency compared to traditional heuristic solvers. Real-world D-Wave use cases. Industry, problem type. Example, organization, Outcome Automotive, traffic routing, Volkswagen, faster optimal route computation, aerospace, cargo optimization, Airbus, better balance and fuel use. Defense, fault detection, Lockheed Martin, quicker anomaly, isolation. Retail, supply chain, save on foods, more efficient deliveries, finance/consulting, scheduling, Deloitte, improved workforce allocation, research/AI, clustering, ML, Los Alamos, improved clustering accuracy, biotech, protein folding, research consortia, faster energy minima discovery, space, mission scheduling, NASA, optimized satellite tasking,